Hi, everyone. Now we're going to talk about the normal probability distribution. Here's an example that I'm going to work out in this video. I hope you have already seen normal distribution. We look at the bell-shaped curve and the area under that bell-shaped curve above the x-axis, we know it's going to be 1. So using that, now we can do some probabilities. Let me also show you the z-score table I'll be using in this video. Here's the z-score table I will be using in this video. Note that some z-score table will read the area to the right or to the left of this normal curve. As you can see, this z-score reads area from particular z-score to the left. So we get everything, the negative values and positive values as well. So just be mindful of that. And also you should know this formula to convert from a normal variable to a standard normal variable. It's always x minus mu, which is the mean, divided by sigma, that's standard deviation. Okay, so let's go back to our example and see if we can find our following probability. Okay, so for this example, scholastic aptitude test SATs are scaled so that the mean score is 500. I'm going to highlight this. This is important. And the standard deviation is 100. What percentage, meaning what is the probability of students taking this test should score 700 or more? So meaning 700 and greater. Assume a normal distribution. All right, so let's go ahead and draw the normal curve. So here is our normal curve. I'm going to label two variables on the horizontal axis. So let's suppose our curve looks like this. All right, so you can't really draw that. Let me draw it one more time. So do your best to draw the normal curve as symmetrical about the mean as possible. So let's suppose this is the x variable. So x is going to represent the normal variable, which is going to represent SAT scores of students. And let's suppose the mean is right at the center where the peak is. This is going to be 500. So we know the mean, which is mu, that's 500 in this problem. So we place that right here at the center. Note that 50% of the area is to the right of the curve and 50% of the area is to the left of the curve. So just keep that in mind. Now we also know the standard deviation, which is sigma, that is given as 100 in this problem. Now, when you standardize your variable x to a z variable, we know that for the mean, we're going to have 0 and the standard deviation is 1. So use the formula z is equal to x minus the mean over sigma to convert from the z variable, from an x variable to a z variable. So we were interested in what is the percentage of students taking this test score 700 or more. So let's suppose 700 is going to be somewhere right here. This is 700. So we want to find how much area lies on this side of the curve. So all of this. I'll show you how to do this problem in two different ways so you can see what's easier for you, or at least you have multiple ways of doing the same problem. So the z-score for 700 is going to be 2, or you can calculate it. For example, you plug in 700 in here, plug in the mean and standard deviation respectively. So you'll have the z-score for 700. That's going to be 700 minus the mean over sigma. And that's going to give you 200 over 100. That's 2. So that's what I put right here. Okay, so we need to know what is the probability that x, meaning the student score, 700 or more, so greater or equal to 700. Now note that our z-score table, or at least the one I'm using, it's going to read the area to the left of a particular z-score. So if I were to find the probability that z is greater than or equal to 2, because 700 corresponds to 2 as our normal for the value of z. So if I were to find, using that table, the area for this guy, well, I wouldn't have that. Instead, I'll get all of this. So on the left side of that z value. So what I can do is I can take the total area, which is 1. So I'm going to use the complement. So I can do 1 minus probability that z is less than 2, which means now once I get this area right here, I'm just going to subtract that way from 1, and that will give me what I want, just to the right side of 700. I hope that makes sense. So that's one way to do it. So let's continue, and then I'll show you another way to do it. Now we go to the z-score table and find what is the area for z equal to 2. And of course, the area will read everything to the left of 2. So scrolling down to our z-score table, this is the negative side of the z-score table. As you can see right here, these are all negative z-scores. We're going to go to the next page. Here you go. So here we start to increase the z-value. So I'm going to go ahead and look for 2. So a z-score of 2.0 is right here and 2.00. So we see that the area of z equal 2.00 is this number. And as you can see, that's a very high area because 0.9772 is the area of all of this. So as I have shown you before, all of this, and that's pretty large area. So if I do 1 minus that area, I get the right side of 2. So this is going to give us 1 minus 0.9772. And then if you put this in your calculator, you'll see that this will give us an area of 0.0228. So in percentages, you can say that this is about 2.28%. And to get the percentages, of course, I moved the decimal 2 places to the right side or multiply by 100. That's one way you can do this problem. Let me show you another way you can do this problem. So let's suppose you draw the normal curve. So another approach to the same problem. So let's go ahead and write that. Another approach to the same problem. Now we're going to use symmetry because if you were to fold this curve right at the center, you have the same area to the left and to the right, which means that if this is a z value is corresponding to 2, then I know that z value right here, it's going to be corresponding to -2. And this will be the same area that we're looking right up here. It's the exact same area by symmetry. So if I can find the area that lies here for this z-score, that will be the same area that lies here for this z-score. So I meant to put this z-score down here. Okay, so that means instead of looking at probability that z is greater or equal to 2, it's going to be the same thing as probability that z is less than or equal to -2 by symmetry. So let's go ahead and look for the area for this z-score now, because we know the table I'm using, it's going to give us everything from this vertical bar to the left of the curve. So I go down, look for negative z-score of -2.0. So it's supposed to be somewhere right here. So -2 right here, 0.00. This is the area, 0.0228. Note that is the same thing that we got by doing the complement right above. So we know this is going to be 0.0228. And in percentages, this is 2.28%. So it's the same idea. So hopefully you understand this curve. You can use symmetry or you can use complement if you're ever looking for area to the right side of a particular z-value. Okay, that's it. I hope this helps you a little. See you next time.